Okay, a few best practices to make your lives a bit easier. First and foremost, where possible, use official images. It's not rocket science, and we said it in the last lesson. They're vetted, documented, and generally speaking, moderately free from vulnerabilities. Alpine here on Docker Hub's a shining example. Look at that. I mean, it's practically a sea of green, right? Pretty safe. And look here, right? Compressed size, 2 meg. I mean, 2 meg. Are they for real? Well, yeah. And that's our next best practice. Keep your images small. Security principle numero uno, smaller is better. It means a smaller attack surface with fewer vectors. In fact, I think a big reason the Alpine repo is so staggeringly free of vulnerabilities is that there's not 1,000,001 packages in the image. Less packages, less potential for bugs. It's security 101. So use official images and keep things small. And that's okay, but what if they don't have what you need in the official repos? Okay, fair play, that happens all the time. All you do is you take something like Alpine Latest and you build on it. That way, you know you're starting from a decent base and you add your app on top of it. It's obviously way better than starting from a huge old image with a bunch of known issues already in there. I mean, yeah. The next thing though is to be explicit referencing images, and we'll get more into this later in the course, but there's a danger in always addressing images using the latest tag. Because for instance, right, Alpine Latest tomorrow might be a totally different image to Alpine Latest today, and the differences between the two can break your app. So be more specific. Using latest in production is just laziness in my opinion. Be more like Alpine 3. whatever, yeah? But that's probably it. Just a few really simple best practices. Now let's go and recap everything. Right. An image is the template for starting containers. It's read-only, and we build it by stacking layers and having the storage driver make it look like a normal file system. But remember, we said it's not a monolithic blob. It's actually a config file plus a bunch of independent layers. And it's inside these layers where all the application binaries and files and libraries and stuff, where they all live. And then the config file has the instructions on how to run it as a container. So how to set the environment, which ports to expose, and how to start the packaged app. Okay, well we can see it's possible, in fact it's normal, to start multiple containers per image. Each container gets its own thin writable layer where it stores changes, and each one of those can be linked back to a single image here. But at no point does any of the data in the layers get changed. They are read-only. If a container wants to change a file in one of them, it does a copy on write operation, where it finds the image from whatever layer it's in, copies it up to its container layer, and makes the change there. We learned that images live in registries. These can be in the cloud or on-prem, and even when we pull an image to our hosts, it still lives in a local registry of sorts. Now we recently got a content addressable storage model. This lets us run a cryptographic algorithm over the contents of a layer and use the resulting hash as the layer's ID, which is great, right? Because it makes the image and its layers immutable. Okay, so the layers get a hash of their contents. The image ID, though, is a hash of the image config file. The result's the same though, right? Change anything in the image config or anything in any of the layers, and the hashes change. Believe me, this has been a massive thing in securing what is a vital part of the container pipeline. Now when we push images to registries, we compress them, and compressing means changing content. So we needed a second hash for use with the registry. It's a low-level implementation detail, but it can make matching things up on the host hard. I mean matching it up for you and me poking around, not for the Docker engine. Docker obviously keeps in mapping, so it's a piece of cake for the engine, but it can be complicated for us. Anyway, on Docker Hub, repos are divided into official and unofficial, and the two are not equal. Official repos are the safest and follow best practices. Unofficial, not so much. In fact, unofficial can be dangerous, but they can also be great. I mean, there's some absolutely cracking projects out there in unofficial image land. You've just got to know where to look. Yes, There's other registries as well, and there's even on-premises ones. Finally, I think we used a few Docker image commands. Push and pull let us upload and download from a remote registry. Inspect gives us the image config, including layer data listed by content hash. I love that command, by the way. And rm gets rid of old images. And that's it. I promise. We're ready to move on and see how to build our own.